Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 22, comparison between a drained and undrained stability of an embankment on clay soil. So in the last lecture, in the previous lecture, we explained the difference between drained, undrained A, B, and C in PLAXIS 2D. So in this example, we will try to compare the difference between embankment on drained clay soil and also embankment on undrained clay soil. So we will model and simulate both situations in PLAXIS 2D, and we will see how it affects the factor of safety between these two drained and undrained condition. So in this lecture, we will see the difference between drained and undrained stability of an embankment on a clay layer using PLAXIS 2D. Also, drained and undrained, it means long-term and short-term. Long-term for drained condition and short-term, it means for undrained condition. So we will see the difference between factor of safety in both condition. Also, we will see how the excess pore water pressure is developed in undrained condition, and we will see the difference between failure surface in both conditions. This is going to be our example. We have 8 meter depth one clay soil layer, and also we have this embankment, and in the left side, the slope of the embankment is 2 horizontal, 1 vertical, and in the right side we have 3 horizontal, 1 vertical, and at the top we have 3 meters. Also, the height of the embankment is 5 meters. So we can see this is the failure surface in case of drained condition. If I change it to undrained condition, we can see this is a failure surface of this embankment in undrained condition. We can see it has more or deeper failure surface. This is because due to development of excess pore water pressure, and this excess pore water pressure decreases the effective stress, so it decreases the shear strength of the soil. That's why. And also, if I clicked on the shear strength in here, we can see this is a failure surface in case of undrained condition, and for drained condition the failure surface is shallower. Also, we can draw the factor of safety versus deformation. So in X direction, if I select the deformation, in here we have node and deformation, total displacement, and in Y direction, if I select project multiplier and sigma m sub SF, which is a safety factor, and if I click OK, and in here I right click on setting and click on node faces, I will only select the safety factor faces. We click OK. So we can see this is a factor of safety versus deformation, and this one in the high safety factor, which is about 2. This is for a drained condition, and this low safety factor is in case of undrained condition. So in conclusion, in drained clay, Pore pressures dissipate and it allows the soil to mobilize its full shear strength, and this is resulting in a higher factor of safety. While in undrained clay, excess pore water pressure develop during the loading, so it reduces the effective stress and shear strength. So this is resulting in lower factor of safety. And this was for this lecture. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.